Another type of problem we're going to see is something called a work problem. So let's imagine, for example, that you and I are going to collaborate on building a website. And I know that it's going to take me 30 hours to build a website all by myself. But we know it's going to take you only 20 hours to build a website all by yourself. So how long is it going to take if we work on a website together? Now, I know sometimes, depending on who you work with, it could take longer, but let's say for this example, if we work together, we're actually going to get more done quicker, which is kind of the point of collaborating. So as we work through and solve this problem, this work problem, we're going to assign a variable to what we're trying to find. And what we're trying to find is the amount of time it will take us to work together. So how we start to unpack this is we want to think about fractional parts of the job. We're going to change our gear a little bit and say, well, how long is it going to take me per hour to get the job done? Well, I think it's going to take me 1/30th of the job done every hour. Does that make sense? If it takes me 30 hours to do the complete job, how much am I going to get done the first hour or every hour? 1/30th. How long is it going to take you? Or how much work are you going to be able to get done every hour? Well, it's only going to take you, or the amount you're going to be able to complete is 1/20th of the job every hour. Now, we're comparing how much time we work together. So we have the amounts that we have. So this equalizes our time. Then from there, the fractional amount per time that I could do, is I get X amount of the job done per every 30. You get X amount of the job done every 20. In this particular case, 30 hours and 20 hours. So how long is it going to take us to get the complete job done or one whole job? Well, we're going to take my effort plus your effort and equal those to one complete job. And now we have an equation, something that we might be a little bit more comfortable with now in solving. So how do we solve this particular equation? Well, we look for a number that we can multiply both sides by that will eliminate the fraction. And that's going to be our lowest common denominator. I'm going to use that in this fashion to go ahead and eliminate my fractions. 60 times x over 30 gives me a 2x. 60 times x over 20 will give me a 3x. 1 times 60 gives me 60. 5x equals 60. X, in this case, equals 12. The question we asked to begin with, how long will it take for us to work together? It's going to take us 12 hours working together to complete that particular assignment, which in this case was developing a website. Now, Willie, this is a little confusing here. Is there something you can do to help me understand how to set up work problems as we start to get the hang of it? Yeah, I kind of do. So let's look at this idea where I can give you this model, which is x over a plus x over b equals 1. Now what that unpacks to, imagine that a is the amount of job 1, however long it takes to complete one job, depending on or how long it takes one person to complete a job, and b will represent how long does it take the second person to complete a job. The x's represent the time of us working together, equaling one complete job. So you will work back to a model that looks similar to that. And I think that you're able to recognize that model over here. X over 30 plus x over 20 equals 1. I hope that's going to be helpful for you as you start to unpack some of the practice problems.